Quick question. Have you ever stood by a window on a stormy night, watching lightning crack across the sky? That blinding flash, that earth-shaking thunder? It feels like the most powerful thing in nature, right?
Now imagine that same lightning, but 1,000,000 times stronger. We're talking about a single bolt releasing more energy than the largest nuclear bomb ever detonated on Earth. This is not science fiction. This is the everyday reality on Jupiter and Saturn, two of the most violent worlds in our solar system.
Today, we're going to unpack exactly how this happens. How do gas giants generate lightning? Why is it so much more powerful than ours? And what has NASA's latest mission revealed in 2026? Before we go to Jupiter, we need to understand our own lightning because the same physics drives it all. Think about shuffling across a carpet in your socks and then touching a metal doorknob. That little shock? That's static electricity. And lightning is essentially the same thing, but on a colossal scale. Inside a storm cloud, millions of ice crystals and water droplets constantly collide. These collisions transfer electrical charge. Lighter ice crystals carry positive charge to the cloud's top. Heavier particles carry negative charge to the bottom. When the difference becomes too great, electricity violently bridges the gap, ripping through the air at 270,000 kilometers per hour. That's lightning. Each bolt on Earth releases roughly 1 gigajoule of energy, enough to power a house for about a month. Impressive, yes, but compared to what's happening on Jupiter, laughably small. In March 2026, scientists at UC Berkeley analyzed data from NASA's Juno spacecraft. They measured 613 individual lightning pulses at Jupiter. Their finding was jaw-dropping. Jupiter's lightning bolts range from roughly the same strength as Earth's up to at least 100 times stronger. And the upper estimate? 1,000,000 times more powerful than anything we experience here. To put that in perspective, if Earth's lightning is a single candle flame, Jupiter's most powerful bolts are the surface of the sun. Jupiter is the largest planet in our solar system, so large that 1,300 Earths could fit inside it. But here's the key detail. Jupiter has no solid surface. Jupiter's atmosphere is dominated by hydrogen. On Earth, our atmosphere is mostly nitrogen, which is heavier than water vapor. So on Earth, moist air is lighter than dry air and rises easily, fueling storms. Jupiter is the opposite. Hydrogen is lighter than water. So moist air on Jupiter is heavier than the surrounding atmosphere. It struggles to rise. It gets trapped.
Imagine pressing down on a spring for years. The moment you release it, it explodes upward with all that stored energy. That's exactly what happens inside Jupiter's atmosphere. Moist air gets suppressed deep in the atmosphere, building pressure and energy. When a storm finally punches through to the upper atmosphere, it releases everything at once, creating extreme wind speeds and lightning bolts of unimaginable power. Jupiter's storm clouds tower over 100 kilometers high. Earth storms reach about 10 times the height means far greater charge separation and far more violent electrical discharge. Jupiter flips this completely. Juno data shows that lightning is almost absent at Jupiter's equator. Instead, it concentrates near the poles. Scientists believe that near the equator, sunlight warms and stabilizes the upper atmosphere, blocking storm development. At the poles, internal heat from deep inside the planet rises freely, creating perfect conditions for violent convection and lightning. You've seen that famous red swirl on Jupiter? The Great Red Spot. That's a storm that has been raging for over 350 years. The storm system is larger than Earth itself. Interestingly, the Great Red Spot's core is actually calm, like the eye of a hurricane. But the surrounding storm bands relentlessly lit up with continuous lightning. Scientists compare it to mesoscale convective complexes on Earth, but on a planetary scale. Saturn. Everyone knows it for those beautiful rings. It looks almost peaceful. But don't be fooled. Saturn's lightning can be up to 10,000 times more powerful than Earth's. Winds howl at hundreds of miles per hour, and it generates some of the most violent weather in the solar system. It just hides it well behind those stunning rings. Just as Jupiter has its Great Red Spot, Saturn has what scientists call the Great White Spot, but they behave very differently. Jupiter's red storm is calm at its center. Saturn's white storms are the opposite, furiously active throughout, brimming with lightning from edge to center. These storms grow so large, they form what scientists call storm alleys, bands of continuous thunderstorms that stretch all the way around the planet. Saturn gets wrapped in its own ring of lightning. Saturn's lightning activity concentrates primarily around 35 degrees south latitude, which scientists have nicknamed Storm Alley. Unlike Jupiter, Saturn's lightning distribution is more tied to specific atmospheric jet streams rather than polar regions. The Cassini spacecraft, which orbited Saturn from 2004 to 2017, spent over a decade listening to Saturn's lightning. It detected radio bursts from lightning that sounded exactly like the crackling you hear on an AM radio during a thunderstorm, except these bursts came from 1.4 billion kilometers away. In 2010, Saturn produced one of the most dramatic storm events ever observed in our solar system. A colossal storm erupted in Saturn's northern hemisphere, so large it was visible from Earth through amateur telescopes. It wrapped around the entire planet within months. Scientists called it the Dragon Storm. Lightning flashed continuously for 6 straight months. For reference, the longest thunderstorm ever recorded on Earth lasted a few hours. Saturn's Dragon Storm lasted half a year. Here's what makes this scientifically beautiful. Jupiter's lightning follows the exact same step-by-step process as Earth's lightning. On Earth, a lightning bolt doesn't travel all at once. It moves in rapid steps, millisecond by millisecond, feeling its way through the air. Scientists call this a stepped leader. Juno detected the same stepwise progression in Jupiter's lightning. The mechanism is identical. The scale is just incomprehensible. Why should we care about lightning on a planet hundreds of millions of kilometers away? Because Jupiter is essentially a laboratory for extreme atmospheric physics. By understanding how convection and lightning work in a hydrogen atmosphere versus a nitrogen atmosphere, we gain tools to model weather on Earth more accurately and to predict weather on exoplanets orbiting other stars. Every time Juno passes Jupiter, it's not just exploring another planet, it's teaching us how weather works across the entire universe. NASA's Juno spacecraft has been orbiting Jupiter since 2016, making it the closest human-made object to ever study the gas giant up close. And in March 2026, it delivered a landmark scientific result. A team led by Michael Wong at UC Berkeley published a peer-reviewed study in the journal AGU Advances. They analyzed 613 microwave pulses captured by Juno during close flybys of Jupiter's atmosphere. In a single pass over Jupiter, Juno detected 206 separate lightning pulses. Let that sink in. Over 200 lightning bolts detected in one flyover. Measuring all 613 pulses, the team found the lightning energy ranged from roughly Earth-equivalent strength up to more than 100 times stronger per bolt. The theoretical upper limit, accounting for measurement uncertainty, could reach 1 million times Earth's lightning intensity. In joule terms, Earth lightning releases about 1 gigajoule. Jupiter's bolts measured anywhere from 500 to 10,000 gigajoules per bolt. Let's put it all side by side. Earth, 1 gigajoule per bolt. Storm height, 10 kilometers. Lightning concentrated near the equator, about 1 billion strikes per year. Jupiter, 500 to 10,000 gigajoules per bolt. Storm height, over 100 kilometers. Lightning concentrated near the poles. Individual storms last for centuries. Up to 10,000 times Earth's lightning power. Wind speeds, hundreds of miles per hour. Storm Alley at 35 degrees south. Single storms lasting up to 6 months. The pattern is clear. The bigger and more energetic the planet, the more extreme its lightning. But the question is, why exactly? Science is honest, and there are still open questions. Mystery 1. Why is Jupiter's equator lightning-free? The sunlight explanation is plausible, but not fully confirmed. Jupiter's magnetic field might also be involved, and we don't fully understand that connection yet. Mystery 2. How powerful exactly is Jupiter's lightning? The range of 100-fold to a million-fold is enormous. The uncertainty comes from measuring radio waves at different wavelengths than how Earth lightning is measured. We need a more direct comparison method. Mystery 3. What about Uranus and Neptune? No spacecraft has ever closely studied their atmospheres. These ice giants may hold lightning storms that dwarf even Jupiter's. We simply don't know. So let's bring this home. Lightning is not unique to Earth. It's a universal phenomenon, a fundamental expression of how energy moves through an atmosphere. The same physics that makes your hair stand up in a thunderstorm is the same physics that has been firing off in Jupiter's clouds for hundreds of millions of years. But here's what I find most profound. Jupiter's Great Red Spot has been raging since before the United States existed. Saturn's Dragon Storm lasted 6 months and wrapped around an entire planet. And all of this has been happening in our solar system, right next door, with zero audience until we sent a spacecraft to look. Juno is still up there right now, circling Jupiter, detecting lightning pulses with every pass. And with each new dataset, we get a little closer to understanding the fundamental rules of weather. Not just here, but everywhere.
If this blew your mind, share it, subscribe, and drop a comment. What other planetary phenomenon should we explore next? Until then, stay curious and keep looking up.